So in this video, we are going to discuss about the properties of Laplace transform. So first one is the initial value theorem. So in the initial value theorem, if we note that mm, what we are going to prove is x of 0 is equal to limit s tends to infinity s into x of s. This is what we want to prove. So generally, if we know x of t, if I take Laplace transform, it will go to, you will get x of s. So the Laplace transform is a mathematical tool which is used to convert a differential equation which is in the time domain to an algebraic equation in the frequency domain or s domain. Okay, so what will happen if I take so you know the formula for x of t, right? Laplace of x of t, that is nothing but minus infinity to infinity x of t e power minus st dt. Suppose for causa signal, you know that um, it ranges from 0 to infinity, right? So therefore, let us take for causa signal. Okay, for causa signal, it becomes 0 to infinity x of t e power minus st dt. Okay, so what will happen if I differentiate dx of t by dt? So what is its value? Okay, so you will get 0 to infinity dx of t dt e power minus st dt, right? So in this, I'm going to take u as equal to e power minus st. So if I differentiate u with respect to dt, I'll get e power minus st minus s dt, right? So what is my dv? dv is nothing but dx of t divided by dt into dt. So that is nothing but dx of t, right? So if I integrate this dv, you will get v is equal to x of t. So this formula is looking like integral of u dv. So you know the formula u dv is equal to uv minus v into du. Okay, so what is u? Integral of u is e power minus st. dv is dxt by dt into dt, right? So you will get this equation, right, from 0 to infinity, right? That is equal to, what is my u? U is e power minus st, v is xt. Okay, so it varies from 0 to infinity minus integral of 0 to infinity. What is my v? V is x of t. What is du? Du is minus s e power minus st dt. Okay, so now if I solve this, e power minus infinity is 0. Okay, so we'll get x of 0 minus x of 0, right? Here, this minus and minus you will get cancelled, so you will get s, right? Integral of 0 to infinity x of t e power minus st dt. So this is equal to minus x of 0 plus s into, this is a formula for x of s. So this is nothing but so you know the Laplace of uh, x of t, that is equal to x of s, right? Capital X of s. So I'm substituting in this equation. Okay, so this is nothing but Laplace of dx of t dt, right? Suppose if I want to get the equation for dx square of dt by dt square, that is equal to s square x of s minus x into x of 0 minus x dash of 0. So this is a formula, another formula. Again, if I want to get d cube of x of t divided by dt cube is equal to s cube x of s minus s square x of 0 minus s into x dash of 0 minus x double dash of 0. Okay. So let me take this equation equal to a. Okay. So now only I'm going to prove. Okay. So the proof is, okay. So from equation a, okay. So I'm going to take the limit. Okay, limit limit s tends to infinity minus x of 0 plus s into x of s. Okay. So that is equal to, so what is the formula for this one? The formula for the equation for this one is here, right? This one. So I'm going to substitute the limit here. Limit s tends to infinity 0 to infinity dx of t divided by dt e power minus st dt. Okay. So again, limit s tends to infinity minus x of 0 plus s into x of s, right? That is equal to, see here, if I substitute for s, I'm going to substitute infinity, it goes to 0, right? So if I substitute infinity here, so this entire term goes to 0. So I will get, okay, minus x of 0. So there is no use in substituting s of infinity here, plus limit s tends to infinity s into x of s, that is equal to 0, right? Because e power minus infinity here is 0. Okay. So from this equation I can write limit s tends to infinity s into x of s is equal to small x of 0. So this is nothing but your initial value theorem. So hence proof. So here the left hand side is equal to right hand side, right? So next to prove the final value theorem. X of infinity is equal to limit s tends to 0 s into x of s. This is a proof. For this, again I'm going to take this equation, equation A, right? So this is my equation A, right? So I can take this equation. So this is equation A, right? So from this equation, I'm going to substitute. So this is nothing but that is equal to 0 to infinity dx of t by dt e power minus st dt, right? So in this equation, I'm going to substitute limit s tends to goes to 0, right? So in this above equation, I'm going to substitute the limit s to 0. Okay, minus x of 0 plus s into x of s is equal to limit s tends to 0, 0 to infinity dx of t dt it e power minus st dt. So again limit s tends to 0 minus x of 0 plus s into x of s, that is equal to, so if I substitute s is equal to 0, it becomes anything power 0 is equal to 1. So I will get 0 to infinity dx of t dt dt. So on solving, I will get only x of t, right? X of t 0 to infinity. This all, right? So here minus x of 0, I can take it common, and plus limit s tends to 0, s into x of s. So if I substitute 0 here, this goes to, sorry, um, here I am going to substitute x of infinity minus x of 0, right? That is x of minus x of 0 plus limit s tends to 0, s into x of s. So here minus x of 0 minus x of 0 get cancelled. So you get x of infinity is equal to limit s tends to 0, s into x of s. So this is your formula for final value theorem. So here they are asked to find the x of infinity and x of 0. So this is nothing but your final value theorem, and this is a initial value theorem. The first problem they are given x of s is equal to 1 divided by s3, right? So this is my first problem. X of s is equal to 1 divided by s minus 3. So here what is the formula for x of 0? X of 0 is equal to limit s tends to infinity s into x of s. This is my initial value theorem, right? So in this I'm going to substitute s divided by x of s is s minus 3. So if I take this s, the denominator common, I will get 1 minus 3 divided by 3 divided by s, right? So this s and s get cancelled out. So if I substitute 1 by 1 minus 3 divided by infinity, anything divided by infinity is 0. So we'll get the answer as 1. So here the x of 0 is 1, right? So the next step to find the final value x of infinity, that is equal to limit s tends to 0, s into x of s, right? So I'm going to substitute limit s is equal to 0, s into 1 divided by s minus 3, right? So here you can see this s is equal to 3, right? S is equal to 3 lies in the right half of the s space, right? So the answer is infinity. Okay. So if you see, this is my s plane. So here the 3 is somewhere around here, right? So this is the value of x of infinity is equal to infinite. Okay. So next second problem. So the second problem is x of s is equal to 1 divided by s squared plus 9 squared. So the second derivative is 1 divided by s squared plus 9 3 square. Okay. So if I want to find the value of x of infinity is equal to limit s tends to 0. Okay. S into x of s, right? So here you can see limit s tends to 0, s into 1 divided by s square plus 3 square. Okay. So this I can write it as 1 divided by 3 into 3 divided by s square plus 3 square, right? So this is in terms of sine function, right? So whenever if I get sine function, okay, so sine function that is oscillator, right? Therefore I can't find the value for final value theorem. since it is nothing but the final value theorem is nothing but a steady state value. So for sine or cos waves or oscillatory waves, we can't able to find the values for x of infinity. Okay. So next, to find the value of x of 0. So x of 0 is equal to limit s tends to infinity s into x of s, that is equal to limit s tends to infinity s divided by s square plus 3 square. And if I take this s square common, I'll get 1 divided by 3 square divided by s square, right? So if I substitute 1 by s as 1 by s into 1 plus 9 divided by s square, I'll get. So if I substitute s is equal to infinity, right? So this still goes to 0. So if we see this initial value theorem will not be applicable, not applicable if the numerator polynomial is greater than denominator. For example, x of s is equal to s square plus 3 divided by s plus 1. So for this one, the initial value theorem is not applicable because it is s squared, here it is s. Next, if it consists of impulse function, okay, impulse function. So the impulse function is a del of t. Okay. So next, let me go for another problem. X of t is equal to 4 minus e power 3t. So if I take the Laplace inverse Laplace for this one, I will get 4 divided by s minus 1 divided by s minus 3, right? So this is a form I get. So if I want to take if I substitute x of 0, I will get 4 minus 1, right? Because e power 0 is 1. So we will get answer as 3. So let me verify this one. When if I substitute limit s tends to infinity s into x of s, I will get limit s tends to infinity s into 4 divided by s minus 1 divided by s minus 3, right? So we'll get 4. So if I can take the 4 common, limit s tends to infinity, right? 1 divided by s minus 3 into s, right? So here 4 minus, if I take the s comma outside, 1 minus 3 divided by s. So in this I am going to substitute s is equal to infinity. So if I solve, I will get 4 minus 1, that is equal to 3. So next, so if I want to find the value of x of 0, is equal to limit s tends to infinity s into x of s. Okay, this is the initial value theorem. So limit s tends to infinity. So you will get 3s square plus 3s divided by s into s square plus 3s plus 2. So on solving, I get limit s tends to infinity 3s plus 3 divided by s square plus 3s plus 2. So in this limit s tends to infinity, so I am going to take s square common. So if I take s square common, okay, so I'll get 1 plus 3 by s plus 2 divided by s square. So in the above term also, if I take s common, I will get 3 plus 3 divided by s. Okay. So if I substitute infinity, this becomes 0. This will goes to 0. Okay. So I will get 3 plus 0 divided by infinity plus 1 plus 0 plus 0. So that is equal to 0. So this is the value of x of 0. So next, in order to find the value of x of infinity, so you have to substitute limit s tends to 0 s into x of s, that is equal to limit s tends to 0 3s plus 3 divided by s squared plus 3s plus 2. So on substituting 0 here, I will get 0 plus 3 divided by 0 plus 0 plus 2. That is nothing but 1.33.